Hey everybody, welcome to today's DP0.3 kickoff info session. Today we're gonna go right from zero for people who don't yet have accounts, all the way through all of the resources for DP0.3, a little bit about the data products, and then we'll quickly make use of the Rubin Science platform, both the portal and notebook aspect, to just give you a little taste. And make sure that everyone can get access to the data. So I don't have slides for today because I'm just going to be using our DP0.3 resources and showing you exactly the same resources that you'll be using to do work with DP0.3. I have the chat open so that I can see questions as they arise. We also have Greg Medeski and Douglas Tucker, who are here from the community science team, who can answer your questions on the fly. And I see various solar system faces here as well today, who can be answering questions more about the data products and the simulation, which we're not going to cover in depth today because we will have special sessions dedicated to describing the simulation later on in the fall. So let's get started. If you're completely new to anything related to Data Preview 0, welcome. Setting up, sharing my screen. So Data Preview 0 is serving simulated LSST-like data products in the same environment as you will use to access the real LSST data products in the future. And in terms of simulations, right now in our Data Preview 0 program, which is going to last all the way up until we have real data from Rubin, we are serving two different sets of simulated data products. They're completely independent simulations. They don't overlap at all. You can't use the two simulations together in any way, and they have very different separate data products. So Data Preview 0.2, Phase 2, DP0.2, was released last summer, and it is primarily an extragalactic and galactic simulation. It's about 300 square degrees in the southern sky, about 5 years worth of images. And then these simulated images were processed with the Rubin Science pipelines, and the data products are available. I only mention that today because it's the Data Preview 0.2 set of documentation, which is what you should be seeing on your screen right now, because I'm screen sharing, at dp0-2.lsst.io. It's in that set of documentation that we still have all of the getting started resources for new delegates. So we're actually starting in that documentation today, but then we'll move over to more about DP0.3. So if you come here to this link, dp0-2.lsst.io, the first thing you see is this, this big important box right here that if you don't yet have access to DP0, you will follow the getting started checklist. Ready access, and you want to go straight to information about DP0.3, which is the separate set of simulated solar system catalogs, then you can follow this here. I'm going to assume that at least a couple of you here don't yet have access or haven't engaged with DP0, and we're going to start with the getting started checklist. So if you come here, you will see a whole series of steps that will help you get started with DP0. It's really only the first 5 that are mandatory that you have to do in order to get access to the data. The first is to review the guidelines and expectations. So we're going to do that right now together. The first thing that's important to know is that in order to hold an account in the Rubin Science platform, which is how you access Data Preview 0, you do have to have Rubin data rights. That means that you have to be a scientist or a student who is employed at or enrolled in a US or Chilean institution, or your name has to be on the list of international data rights holders. So that's the first guideline. So if you don't fall into either category, or you're not sure if you fall into either category, I might not be able to approve your request for an RSP account today, but we can get it figured out later. On your own time later, there are some risks and caveats regarding using the Rubin Science platform as it is now, and that's mostly just that it is under active development. Things change. The version of the LSST Science pipelines that are automatically installed, we update it regularly. It's a sort of a changing and dynamic environment to use. And of course, as always, we have a code of conduct for everything related to our DP0 program, and there are some citation policies for you to follow. So that's getting you started with guidelines and expectations. The next step, if you don't already have one, and here's where some of you might be taking this action today, is to submit a petition for one of the Rubin Science Platform accounts. So this process, there are instructions here if you're following along with me to get an RSP account. I'm going to go through those. The process is essentially, I think you can sort of skip the top part that we've already talked about. And then there are step-by-step instructions here. And the first is to go to the home page for the Rubin Science platform. So you point your browser at data.lsst.cloud. And then the first step, if you don't have an account, you just try to log in and it will prompt you to make an account. Since I already have an account, I can't quite simulate this process for you live. But if you don't yet have an account, please do come here and get started while I'm talking, because in about 10 minutes, I'm going to pause talking to you about DP0 resources and go and approve anybody's new account that they've just requested so that you can join us for the hands-on part in the second half of this hour. And as you work through the step-by-step guide to getting your account in the Rubin Science platform, if you end up with questions, just pop them in the chat and we'll try to help you live so you can get all set up today. The process is essentially going to be you provide an email address and you choose an identity provider. If at all possible, please just use your institutional affiliation as both your email address and your identity provider. That makes it a lot easier for me to confirm your data rights and approve your petition. However, using GitHub and ORCID as your identity provider is also an option, and using other email addresses also will work. It just might take me longer to verify your data rights. I will say also that once you have set up an email address and an identity provider, once your account is approved, you can go back in and add multiple identities. So if your first step is to use your institutional affiliation as your identity provider, but you prefer to log in with GitHub later, that is possible. We're not going to demo that today, but it is possible. Okay, so we've got presumably a bunch of you going through getting your accounts. I'm going to keep kind of going through, where was I? The checklist of how to get started while some of you are doing that. So back to the checklist. The third important thing is to set up your account in the Rubin Community Forum. And there is more information about what the Community Forum is here. You access it at the URL community.lsst.org. And the reason why this is important is because the Community Forum is basically also the help desk. So if you come to the forum and you land on this landing page here, you'll see there is a news category right at the top that has lots of news from our communications team. But there's then the next most important one is the support category. And this is one that if you're not logged in, you can always come to support. You can search the forum to find various topics, questions that people have asked. But once you are logged in, you can come here to support. There's even a subcategory, especially for getting help with Data Preview 0. And when you do need help with something, you run into an issue, you don't understand a data product, you're working on a paper and you're not sure like which column in the catalog is more appropriate to use. Literally any question you have, you can come here, click on new topic, type a short title, and then you can describe your question here. If it's an issue you've encountered, you can upload screenshots, and then Rubin staff see this and are able to help you. So that's why step 3 of the Getting Started checklist is to make sure you have a Rubin Community Forum account. And for this, data rights aren't required. Anyone can have an account here. Here you can also use GitHub as your identity provider or just an email. There's no restrictions on use of the forum here, but it is very useful if you're going to be doing stuff with DP0. So it's the 3rd step in your Getting Started checklist. The 4th step is to watch a recorded kick info session. You don't have to do that. You are in kickoff info session right now. And so you're getting all the information that you need to know here. And then the 5th is to review your options for getting support. We already went over one of them, which is the Rubin Community Forum. But there is another instance as well. So we also used GitHub issues in some cases. These are really good for like little bug reports, or you have trouble logging in, or you forget your password, or you change institutions, and now you need to change your identity provider in the forum. So very like small technical things are good in GitHub issues. Generally, it doesn't really matter if you use the forum or GitHub issues to report a problem or ask a question. We see it either way. We just like to give you multiple options for how to get assistance from Rubin. All right. That covers the basics of the Getting Started with DP0 checklist. I'm just going to pause for a moment for questions. Okay, no questions so far. I'm going to show you a couple more useful things that are in the documentation before I take a break and approve any new petitions for Rubin Science Platform accounts that might have come in. So coming back to the Getting Started with DP0 checklist, 1 through 5 are sort of the mandatory things that are very much recommended to do if you're getting started with DP0. And then down here we have 6 through 11, which are sort of optimal steps to, oh, we got one question. Oh, support staff. Yeah, I'll let them take it. Oh, actually, Tom, this is important that we will cover later too. In the notebook aspect of the Rubin Science Platform, in your notebooks/tutorial notebooks directory, which is default for everyone, that's a read-only directory. So if you're in that particular directory, notebooks/tutorial notebooks, you won't be able to do a git pull. You will automatically have the most recent version of your of those notebooks. Yeah, you're used to using Git. Yep. Okay. Okay. So the optional but recommended steps are number 6, to work through the various tutorials that we have. I'm going to show you how to find the DP0.3 tutorials later today. Reviewing the data products definitions for the data set that you're interested in. I'm going to show you where to find that for DP0.3 today. Following step-by-step introductions for the RSP's portal aspect and notebook aspect. So these are our 2 links that you can follow to get like very sort of high-level overview, very general step-by-step instructions for using the Rubin Science Platform. That's not quite a tutorial. They don't really have like a science goal or anything. They just sort of show you what it's like to use the portal. And I am going to just kind of quickly show you what's in here. So if you just wanted a really general overview of what the portal is like, you can come here and scroll through. It's showing you screenshots of what it looks like to use the portal. We're going to actually do an example later today. But this is a nice place to start. You just just getting started with the portals, you can come and work through this. And if you're completely new to Jupyter Lab or Jupyter Notebooks, we also have this page that's a very general introduction to logging in to the notebook aspect, which I will also show you later, but it's all here for you. So my point is kind of that everything I'm going to show you today, it exists in the documentation and that you can access it again at any time. So there's stuff here about, how to use various aspects of the Jupyter environment, how to use the tutorials. There's a bunch of FAQs in here. For the notebooks, just lots of good information if you're new to Jupyter Notebooks. That is there for you to review. The other thing is, so you are in one of our DP0 virtual seminars right now. These delegate assemblies, they happen every other Friday, interspersed with what we call Stack Club. So to find out more about which virtual seminars are happening and when, that is also here in the documentation. So for the delegate assemblies, that one is happening now. So you're in this one. But coming up every other Friday, we have lots of DP0.3 content for you. So you can come here. It's always the same Zoom link to any of these sessions, and everyone is welcome at all of them. So got lots of good stuff coming up. These will all be tutorials. Some of them will be presentations, sometimes like more hands-on stuff. On a Friday that we're not doing a delegate assembly, it is instead what we call Stack Club. And this is just an open drop-in session. Ruben staff are always there. Usually people come and they say, oh, today I'm going to work through like notebook tutorial number 3, and they can do that sort of on their own or in a small group if other people are interested in the same thing. And Ruben staff are there on hand to answer questions. If you're having trouble with anything related to DP0, like you're trying to work through an analysis, but it's not turning out like you thought, drop into Stack Club, ask one of the Ruben staff, sort of show them what you're working on and show them what your issues are. And it's a good way to sort of get assistance. Sometimes people come together in a small research group and they come to Stack Club because they're all sort of working on a DP0 analysis together, and we make a breakout room for them and they sort of share what they're working on, and they go off and work for a while and then they come back and share what they found. So it's kind of a nice way to just co-work, to learn, to get support. All that kind of stuff is what Stack Club is for. All right, so that's your delegate assembly schedule, your Stack Club schedule for the virtual seminars. And then there's a couple of other suggested delegate activities. So if you've got your RSP account, you have access to Data Preview 0, but you're still not really sure what to do, that's okay. We have some suggested activities for you, so you can check those out if that's your situation. And then the 11th thing is to be aware that as users of the Ruben Science platform, there is a users committee who is charged with meeting twice a year to discuss various issues and advocating for things on your behalf. They are contactable. They have an email address, which I will pop in the chat. And you're free to contact them at any time. We'll have some more options later in the fall for you to interact with the Ruben Users Committee as well. So that kind of takes us through the entire checklist. That's gives you options for getting to know more about the Ruben Science platform, where to go to ask questions when you need it. I'm going to pause and stop screen share now, and I'm going to check for new requests for accounts in the Ruben Science platform. Now is a good time to ask questions as well while I do that and make sure new people are set up. I actually don't see any new requests for Ruben Science platform accounts. Did anyone try to follow the instructions for getting an account in the RSP? and run into trouble immediately that we can help with? Because I don't see any new requests. Yeah, maybe everyone here just has accounts already, that's great. You're all up and running already. Okay, we're gonna keep going. If you did try to get an RSP account and you ran into issues right away, you don't want to bring it up now, after the first hour, so at the top of the hour, I will. Yes, Charles, I know about your account. We're still verifying the data rights on that one. So I do see your request. I just can't authorize it yet. Yeah, so at the top of the hour, I will ask again if anyone encountered issues or errors or error messages from their attempts, and we'll try to sort you out. Then. All right, back to screen sharing. Okay. So from here, you've got your getting started with DP0 checklist. You can work your way through it. I'm going to show you first. So right now we're in DP0.2.lsst.io, but if you instead go to DP0.3.lsst.io, you will see the new documentation has like a completely different style from the old one. But also this is the documentation that entirely covers DP0.3. So your first stop here is probably going to be the description of the DP0.3 data products here. It starts off at the top. There's a description of the simulation itself. And I'll point out that we will have Pedro and Jake give a delegate assembly on Friday, September 29th. That's going to cover in much more detail the simulation itself. So keep an eye out for that, Friday, September 29th for Jake and Pedro. But you can also read through this to get a little bit of background information about how these solar system catalogs were simulated. If you keep scrolling down on this page, you'll find more information about the specific tables that are being made available for a DP0.3. There are 4 of them. They're called DIA source, SS object, SS source, and MPC orb tables. Here there are schema browsers for the 4 tables. So you can see here under schema browser, if you click on this link, you get a nice set of tables. You can page search this if you're looking for a particular column, where all the columns have descriptions and units. It's a good way to sort of take a high-level look at all what is in the catalogs. And then this table has a couple more descriptions as well for what these catalogs are. So very, very briefly, the 4 catalogs, DIA source, SS source, where SS stands for solar system source, and DIA stands for difference image analysis source. These 2 tables are sort of on a per visit basis. So the DIA source table has every simulated detection of every moving object that is in the DP0.3 relation. So that's every source is every detection of a moving object in a difference image. So that's the one that has like a pair of magnitudes. It's got some shape information, I think, in this DIA source table. It's got like the time of the observation, the RA index of the observation, the filter. So all of this is like per detection in DIA source. Solar system source table is the sort of the more the physical information about that moving object at the time of a given LSST observation. So it's got the 2D sky coordinates at that time, but also the three-dimensional, like the distances, the velocities of that object at that time. So DIA source and solar system source, because they're per observation by LSST, those two tables are one-to-one and they can be joined. The SS object table, on the other hand, for every solar system object is a linking of all the DIA sources. So you have a many-to-one connection between DIA source and solar system source to the SS object table. So SS objects, solar system object table, as you can see here, it has sort of summary information about the observations. For example, the best fit absolute magnitudes in G, R, I, and Z are all in the SS object table because that's a per object quantity, not a per observation quantity. I have to note here that although you can see there are columns for U band. If you scroll down more, you'll find there are also columns for Y band absolute magnitudes. There aren't actually U or Y band simulated magnitudes in the columns, so those ones are going to be empty. The final table is the MPC orb table, and this is the one that has all the orbital elements in it. So this one is also per object, but MPC orb has, so for example, you can see like eccentricity, inclination, perihelion distance, all those kinds of things that are per object orbital parameters are all in the MPC orb table. So you can find all of those descriptions for the different tables here in the documentation. All the columns for the tables are in the schema browser. And if you keep scrolling down, we have a bunch of sort of additional information about accessing the tables and querying the tables. So some information about like the sizes of the various tables, sorry, make this bigger. Which columns are unpopulated. Like I just mentioned, there's no Y or U or Y band information. Which tables can be effectively joined to the other because they are one-to-one or they're linked in some way. How to make non-random and random subsets of the data when you don't want to use like everything and you're just exploring, and some stuff about flagged rows and the truth data. All of that is here. We're not going to go through every single thing in detail today. But I just wanted to make you aware of what exists in the documentation so that you can find the information on your own later. All right, so that's a bit of a crash introduction to the DP0.3 catalogs. First, we're going to go to the portal, and altogether, we're going to log into the portal and we're going to do a very simple query on the SS object table, and we're going to make a simple color diagram as our first like hands-on thing today. Then after that, we're going to go into the notebook aspect and take a quick run through tutorial notebook number 1. So I'm going to pause again for questions about the data products that you might have, because we're not really covering the simulation or the data products in depth today. I want to go straight to access, but we can take questions now. Okay, let's access this data. So in a new browser tab, you can use the URL data.lsst.cloud. You will find this homepage for access to the Rubin Science platform. Let's use the portal first. So if you click on portal, it will take you to this interface. The first thing you will probably notice is that data preview 0.2, DP0.2 remains the default service that appears when you come to the portal. But up here in the top right corner, you will see options for more tap services. And if you click on show, you get another menu item up here where you can select your tap service. So we're all going to switch to LSST DP0.3 SSO tap service. Yes, Meg, the benefits of using the portal over a Jupyter notebook. So especially if you're new to a given data set, the portal is great for exploring that data set. So you can see here, now that I've got DP0.3 as the tap service, and I've got the DP0.3 catalogs, and looking at the 10-year one right now, although there is an option for the 1-year equivalent catalog here. We're just going to use the 10-year today. So here in the notebook aspect, you have programmatic access to the catalogs, but here it's much more browsable. So this is why we like to start in the portal, because you can sort of see everything right away. Just in this drop-down menu, you can see the 4 catalogs that we have, like the 4 tables that are here. And the first thing we're going to do is switch to the SS object table here, and you can see right away that when we were in the DIA source catalog, that's per observation, and this one does have RA and DEC in it, so you could do a spatial search, like a cone search, for example, at a given set of coordinates, and the portal already knows that this is an option for you, so it's got spatial search as an option here. So you could put in coordinates to find a given object in this table. And you'll notice that when we switch to SS object table, this is per object. So one object, a source is a detection, like DIA source and solar system source are for a given visit or for a given difference image, whereas the object is the moving object. So solar system object table contains like the summary parameters of all of the individual detections by LSST. That's why solar system object, for example, has absolute, like best fit absolute magnitudes. The H magnitudes are in object because it's per moving object, not per detection or per source. So you can see here that the solar system object table, this does not have RA index in it because it's per object, not per detection. So it automatically has changed over here at the left. We're not doing spatial searches on this. So this is nice as well, a nice feature of the portal that it knows things already about the catalog. So the search that we're going to do, a very simple first search, is we're going to retrieve the H-band magnitudes, the absolute magnitudes in G, R, I, and Z for a bunch of bright objects, a bunch of bright moving objects. Very simple first query. And we can do this by using the table that's here. So if we want to retrieve the G, R, I, and Z band H magnitudes, then we select those column names. And if you're looking for just H-band magnitudes, for example, you can use the little search bar up at the top and say, I'm only really interested in columns that contain _H. And that gets you a shorter list where it's easier to go through and select G, R, I, and Z H-band magnitudes. So hopefully you're doing this with me. When we don't want to apply that _H filter anymore, you can just remove it. Now we're back to the full list of all available columns. And if we only want to see what we have selected, which columns of data we're actually going to retrieve in our query, you can click the little funnel here. Is there a way in the portal you can save your configuration so you don't have to do that anytime? There is not exactly, it will stay like this until you remove it, but the actual better way if you want to repeat queries is to use ADQL. And I'm going to show you that now as well. So Here we've got a query set up where we want to retrieve these 4 columns. And before I said bright as well. So let's add a simple constraint on each of these columns where we're only retrieving objects that are brighter than 20-second magnitude. We can put that in for all 4 columns. And now we've got a query set up that will retrieve G, R, I, and Z. Yeah, sure, maybe it's still faint, but this works fine for the demo. So we've got this set up like this. Notice down at the bottom that there's a row limit of 50,000. This does not guarantee that you'll get a random subset, but it will give you just like any 50,000 from the database, where remember on the back end, things have been organized in a way. So it might not be a fully random data set, but it'll be like some 50,000 chunk from somewhere in the sorted list. So if this is a query that you might like to make repeatedly, or you prefer a more like code-based style for making your queries, then you should be using ADQL instead. That's the Astronomy Data Query language, and it's very similar to SQL. One of the nice features for the portal too, to help people who are using or just learning how to use SQL or ADQL, is that once you have a query set up, you can click this button down at the bottom that says populate and edit ADQL. And it takes you to this page where you can see here how you could have scripted that particular query in the ADQL language. So you can see here that it's saying to select those 4 columns from the table that we already selected, and then it has a where constraint where it's applying these constraints on this query. So in the portal, you don't have to use the user interface like this to set it up. If you know, I struggle with joins, is that something the portal can do to show you the ADQL? No, you can't set up at the moment a join in this interface, in the user interface. You can only do single tables right now in the user interface. So if you struggle with joins, which a lot of people do because they can be pretty complicated, we have many more examples of table joins in our tutorial notebooks, and also a little bit of join information, like a join advice in the documentation as well. But I think you'll find the tutorials will eventually be the better place to go for joins. So once you've got your query set up, you can go to the bottom left and click search. And just in case you've fallen a little bit behind, I'm going to copy paste the ADQL for this particular query right into the chat. So I think you should be able to copy from the chat and go straight to the edit ADQL if you've fallen a bit behind, but also want to execute this query. And then when you're ready, from either this page or from this page, you can click search and it will go. And now we have a default results view. So what has happened is that we have the table of all of our results over at right, and at left, it's made you a default plot. It's just plotted the first 2 columns versus each other. That's nice and handy, but we came here to make a color plot. So we need to manipulate the default plot a little bit to make it color. Can come up here to the double gears icon, which is the chart options and tools. Hovering over anything in the portal shows you what that particular thing does. And let's make x-axis I minus z, and we can make y-axis g minus r. And gray is nice, but you can change the color sequence as well to be anything. So that's exactly the color you like. And then, oh, my internet connection is unstable. I'm sorry if I'm cutting in and out. Well, once you click apply and then close, you have a color diagram. And then you can zoom in on it a bit if you want. That's a really, really quick demo of how to do a query in the portal and how to manipulate the plot a little bit. If you're interested in learning more about the portal, in 2 weeks on September 1st, the delegate assembly at this time is going to focus entirely on portal tutorials 1 and 2. And Greg Modeski is going to lead that one. Any other questions about the portal? Did anyone run into any errors when attempting to make this plot or do this same query? Are there any solar system specific features being developed for the portal? That I actually don't know. That's a good question for our RSP team.
Hey, Melissa?
Yeah, Leanne?
Yeah. Flavia, yes, such as what, for example? No, it wasn't Flavia's question. The person who asked about the specific solar system features developed for the portal, like what, for example? I mean, what would you like to see that would be different from orbit cutout tool? Okay. I think the answer to this is no. On our, at the moment, on our list of our feature development list set of requirements and so forth, we don't have anything that I can think of at the moment that is solar system specific, but it'd be great to get your input. That doesn't mean we can't necessarily do it. Do you have an example of an orbit cutout tool in action on another portal like science platform service somewhere that we could take a look at? Okay, MAST has one. Okay, that's all right. We should get your input on that, and if there's anything else as well that you think that would be very useful in the portal aspect, I will talk to Gregory about that, who's the science platform scientist, and look what we can do.
Okay, and now for Flavia's question about retrieving magnitudes of a single solar system object. Yes, you can do that. So one thing to do when we did this query on solar system object, there's so in the SS object table, too much. Okay. There's a column called SS object ID. And so if you had come here, or if there's a particular object that you're interested in, the best way to go about it is to figure out its SS object ID. And so if you were starting with the MPC orb table, because I noticed your question was specifically for like a named, yeah, if you wanted to find like the observations by LSST for a certain named object, the process would be you start in MPC orb. It has proper names for things. I thought it maybe designation. Yes. Yeah. So MPC orb has the full designations, so proper names for individual solar system object. And I think, yes, this version of MPC orb also has the solar system object ID, which is an LSST specific identifier. So you could use these two together to find for a given object of interest. And then once you had that solar system object ID and you wanted like the apparent magnitudes of all of the observations, you could come to DIA source. You would have an SS object ID of interest here, and you could put it in as saying, I only want observations for an SS object ID of a given, and it'll be like some really long number, and you would put it in here. So that's one way to use the portal to find individual observations of a given object. This is a little bit easier to do in the notebook aspect because you can do table joins and kind of do it all in one step. So there will be parts in the notebook aspect that are better for that. More questions. What about comment.dat for comments? So there are comments in here, but you have to do a search on NPC orb and identify them using their orbital elements. One of our notebooks will, I think, include, notebook 3 is still under development, but it will do that. So just before we move on to notebooks, back in the DP0.3, DP0-3.lsst.io documentation, if instead of data products, you go to tutorials, you will see that there are 2 portal tutorials here already that will lead you through much more in-depth examples of how to access all of the various tables. So you can go through here, you can read a lot more about the tables themselves, and then go through additional step-by-step examples of how to query the tables, how to make multiple plots, how to customize your plots, all that kind of stuff. So if you did enjoy the portal demo, come here and work through the portal on your own, or come back in 2 weeks and you'll get a guided tour. Let's now pop over instead book asked. So your starting point is again, data.lsst.cloud. You're at the same landing page, but now you're going to enter the notebook aspect. Pretty much always you're going to leave the image, which is the version of the LSST science pipelines that will be available to you during your session at the recommended. So always leave that at the top. This over here, the options to pick a small, medium, or large container, that will probably change in the near future. It's fine to just always pick large for now. Some of our tutorial notebooks in here do require a large container, so it's fine to just pick large when you come here, unless you've only come here to like do something very small and you're not even touching any data. Just pick a large and get started. It will start up your session for you. This usually takes a minute. Okay, and here's the main landing page that you will encounter. Over on the very leftmost side, if the file icon is not selected, select it so that you're seeing your workspace, like the file system for your workspace. And since I've been on the RSP for a while, I have lots of different workspaces in here, but the one that you will all have automatically is the notebooks file folder. So enter that directory and you'll see there's one called tutorial notebooks, and you go in there. And now this is your notebooks/tutorial notebooks directory. This directory is read-only, and it always contains the most up-to-date versions of Rubin Observatory's tutorials for both DP0.2, so you can see there's a whole bunch for those so far, and then for DP0.3. Right now for 0.3, there are 2 tutorials. One is an introduction to all of the various tables, an introduction to how to query them and join them. And then tutorial number 2 on main belt asteroids is also already there. If that one's of interest to you, we're going to be covering it on Friday, September 15th in the delegate assembly that day. It's going to go step by step through tutorial notebook 2 for DP0. 2 more are in the works, one that looks at trans-Neptunian objects and one that does phase curves. And we expect those to be ready over the next couple of weeks to a month or so. So as you come back and you log back in, you will see new tutorials appearing in this directory automatically. For today, we're just going to open up DP0.3, 01, Introduction to DP0.3. You can open up that one. I also wasn't planning to do like a very detailed step-by-step run through this notebook. I just kind of wanted to show you what's in it so that you can run through it on your own time later. It's pretty basic, but it should be good if you are new to notebooks, if you're new to Python, new to SQL, ADQL, all of that really sort of takes you from 0 all the way up to accessing the DP0.3 data products. So, during a dedicated tutorial where we go step by step, we might come through and, I would talk a lot more about each section and what it does. To execute a given cell, you can use the little play icon that's up at the top, or if you click in the cell to select it and then press Shift Enter, it will execute that particular cell for you. So you can go through this notebook step by step, reading through all of the narrative that we have here, learning how to start up the SSO, the Solar System TAP service, learning how to discover what's in. So this is here like learning to figure out what tables are available, whereas in the portal we had drop-down menus and it was very clear what tables were available. Here you have to use TAP and SQL to sort of query the services and find out like what tables are available. And so you can see here, it's sort of similar to those drop-down menus that are being printed out here, but you're accessing the same data just in a different way. And so instead of like really going through this step by step, since we just have 10 minutes left, one thing you can do, especially with our introductory notebooks, it's always fine to do this, is you can come here to the kernel option in the menu and say restart kernel and run all cells. So instead of going Shift Enter through everyone, especially for the notebook aspect, for our introductory tutorials, it's fine to just run all cells. So we can restart and it will go through and it will execute all of them for you. So while this notebook is executing all cells and doing all of the queries, in case you're new to notebooks, I wanted to point out that there's built-in table of contents functionality over here in the very leftmost menu. You can see there's this bullet list icon, and that's going to give you the full table of contents so you can see everything that this notebook is covering. And you can also see how far it's got along in its execution of all of the cells. So this particular introductory notebook, it goes table by table, each table one at a time. And it shows you the size of that particular table, how to get the size. It shows you what columns are available in that table and how to get the column. This is the same as using the portal and just using the drop-down menus. For columns, it's also the same as using that schema browser that I showed you before. It's got some instructions on how to retrieve a random subset of objects, which is really nice when you're just trying to learn what kind of data is there and you're trying to sort of get small random subsets and make some plots. And then for each of the tables that this notebook covers, it makes like at least one plot of some aspect of column values that were retrieved from that particular table. So this should be pretty helpful if you're just starting out with notebooks and you want to explore what's in each of the DP0.3 tables. And then down at the bottom as well, you'll find in all of our notebooks, we provide a couple of exercises for the learner. So once you've kind of run through all the other sections of this notebook, and now you want to try something for yourself, we have a couple of guided exercises to help learners. And this is good for students and kind of good for everyone as well to do. All right. So I'm just going to kind of quickly scroll through and we'll just sort of hit the plots that get made for each one. So you can see lots of information about the tables. So this is for MPC orb. We're plotting histograms of some of the selected columns. So you can see here, it's all the orbital parameters that are in the MPC orb table, eccentricity, inclination, etc. We're just making some histograms of them here. For the SS object table, the notebook goes through and makes a color diagram, just like we did for the portal, but you're doing it in a more programmatic way. So it's retrieving the same columns, it's making similar colors, and then it's making those color plots, just like we did in the portal, but doing it in the notebook aspect. So it's a nice comparison to give you an idea of how you can do the same thing in the portal versus in the notebook. For the solar system source table, it goes through, and here we plot the locations of one SS object. So this is, if you see this, it's plotting heliocentric coordinates versus and topocentric coordinates for one object. So remember the solar system source table, where's the physical parameters for an object at the time of every LSST observations. That's why you can see that the orbit for this particular solar system object isn't uniformly sampled, because these are when LSST would have observed this particular object. So it gives you a little bit of an idea of what it's like to obtain SS source data for a given object. And then the last one that it goes through is the DIA source catalog, which are the detections by LSST in all of the difference images. And so here we've got time domain data. And as a very simple example for this one, we've just plotted the right ascension and declination of one moving object over the 10 years. So you can see here again, it's not an even sampling, but yeah, it's a moving object, so it's moved all over the sky over the 10 years. So this is here for you to run through on your own at any time. And yeah, we're at the top of the hour. So that kind of takes you from not having a Rubin Science Platform account all the way through to accessing data and making plots with the DP0.3 catalogs. And we'll pause here and take some more questions. While you're thinking of your questions, I'm going to make sure that you have the direct link to the upcoming. Yeah. Our upcoming delegate assemblies. Yeah, so this one was very high level, but if you want to dig in more to portal tutorials or notebook tutorials, or learn more about the simulations, definitely come back in future Fridays. Yeah, so deciding between using the portal or notebook, it depends a lot on what you're trying to do. And really, we kind of recommend that people try stuff in the portal. Like the only way to really know which option is good for you is to try both. There are things that you can't do in the portal. So for example, portal is great for discovery, for trying out different SQL, different ADQL things. It's great for making sort of simple plots. It can do scatter plots. It can do histograms. and it can do heat maps. What you can't do in the portal, for example, is get some data, make a plot, and then fit a function to that plot. As soon as you're doing fits or modeling or any more complicated plots than scatter, heat map, or histogram, then you will need to be using the notebook aspect and using your favorite plotting package like Matplotlib or Bokeh or Seaborn or whatever it is that you use. Is there any use case that would want joint access to other tables and the solar system data? Yeah, so you can't do that now in Data Preview 0, but in the future, for example, there won't be, so that DIA source table that we have now in DP0.3, that DIA source table for 0.3 only has moving objects in it. But in the future, the DIA source table will include every detection in a difference image. So it would have moving objects, supernovae, variable stars, AGN, all of those detections would be in DIA source. When checking follow-up, moving over background. Yes, yeah. Yep, in the future, yeah. And in the future, it will be possible to join. We'll be able to join solar system tables and the data release catalog. No. So solar system tables, right, they are from the prompt processing, which is the daily processing. And you won't be able to like join by SS object ID to a data release static sky. You won't be able to do that. Give me all SS sources that are fuzzy and not near galaxies. You would have to use the coordinates, I think, in that case. And actually, for that particular use case, the alerts, see, DIA objects will have 3 nearest stars, 3 nearest galaxies. But I don't know that SS object has 3 nearest stars, 3 nearest galaxies. All right, we'd have to check the DPDD to see if that, yeah. Yeah, we'll see. I don't think it does, though. I don't think it's planned that SS object has 3 nearest data release objects. This is in response to Mario's question. Yeah, okay, looking it up, yeah.
Yeah, I don't see it in the DPDD, Melissa. I think you're right.
Yeah, I think it's only DIA object that gets those. So, but I mean, maybe that's an oversight.
No, actually, the SS source table, Melissa, has the 3 closest objects.
Oh, it's a source.
Clumping object. Yeah, it has the 3 closest objects and then the distances to those 3 closest objects.
Oh. Okay.
It's not in the object tab, it's in the source table.
Yeah, I guess that makes sense.
Yes.
Yeah, okay, that makes sense. Okay. I'm gonna stop sharing and also gonna stop.
So can I say something to Meg's